Greetings everyone. Today we're going to explore function compositions. For this, you'll just need your notebook. You're going to take notes on your own paper, and of course our writing utensil and calculator. Today we're going to talk about function compositions, and you have actually learned this before. The difference now is in Algebra 2 that instead of substituting in, let's say, a single number or letter, you're going to be substituting in an expression. Remember, keep an eye out for the pencil on each slide, and that's what you'll need to write down. First, let's discuss the basics of function operations. To perform any kind of math operation using functions, you substitute the rule for the function name and simplify. You could really narrow that down. We need to substitute the function rule in and simplify. So, for example, if I tell you the function name f of x has the rule negative 2x, and let's also have the function name g of x, and its rule is 3x plus 1. If I ask you to add f of x and g of x, you replace f of x with negative 2x, you replace g of x with 3x plus 1. So your first goal, as always has been, is to replace first. Then you want to use your operational rules to simplify, calculate whatever would need to come next. As always, if you need to pause for a moment to jot things down, please do so. So let's talk specifically about the vocabulary of function composition. And what that means is we're going to composite a function. So we're going to take one function and substitute it into another function. Now, the way we have to read these is from the inside out. So if I tell you that f of x is negative 2x and g of x is 3x plus 1, we've got two rules there, right? The red and the purple. If I ask you, and here's what's going to be a little bit newer, if I ask you for f of g of x, we want to start off with the f function. So I'm going to start off with negative 2, but instead of x, I always start off with a blank parenthesis. It says, hey, inside of the f function, let's work in out. The inside is going to be g, which is 3x plus 1. So again, we want to start with the f function. Wherever there's a variable, leave a blank. Wherever there's a blank, plug in the inner function. That right there is the toughest part out of all this. So if you think that part's easy, great. If you have to work on that, that's the expectation. Because from here, now we're going back to Algebra 1 rules, right? I'm just taking a look. I need to distribute. I need to simplify, combine like terms, do anything I need to do to get it down to a simplified expression. One way to think about function composition is how would you prefer? Do you want to have pizza with pineapple in it? Or do you want to have pineapple with pizza in it? What do you think? All right, for our examples today, what I need you to do in your notebook is up at the top, I want you to create this green box I have, and we're going to write those 4 functions out. You're going to reuse that for every example. So you're only going to write those 4 functions once. So please pause the video right now and jot those down. All right, hopefully you've got those written down. On each slide, I'm going to present a new example. So in your notes, you're just going to label it EX1. And in this case, we have h of negative 2. So the first thing I need to identify is I'm going to use the h function. So I'm going to write the h function, but wherever there's an x, I'm going to put parentheses. Wherever there's parentheses, I'm going to plug in a -2. So these are what you're used to, right? This is going back to Algebra 1. If I said, hey, x is -2, plug it in. That's all we're doing here. And then we're going to simplify. Of course, we're going to up the game a little bit because you're squaring a -2, which becomes a +4. You have a negative times a negative, which becomes a +4. Remembering your PEMDAS rules that you're going to multiply first and then simplify completely. For the rest of the examples, you don't need that box, right? You've got that written down in your notes already. So all you need to write down is ex2 and j of g of x. So let's start off with j. I need to write j as a function, but wherever there's an x, I'm going to put parentheses. And inside of j, I need to plug in g. So inside of j, where there's a gap, I need to fill in the g function. That's the toughest part of this, because now we're just following our basic PEMDAS rules, simplify, combine what you can. I don't even have any distribution going on here, so I really just need to combine those constants to a -8. Let's look at ex3. Again, same functions, don't rewrite them, just write ex3 and g of f of x. So we're going to start off with g, which is this function here. Ooh, we have 2 x's. Okay, wherever there's an x, put a space, a gap, a parenthesis. Think of it like a template, right? You're going to start off with that foundation and you're going to fill in the blanks. Use some type of notation. I've had students that actually draw boxes. You could do that. I'm a fan of parentheses because we tend to use those just more often in math. Now inside of those parentheses, we want to plug in f of x, which is -2x, into every set of parentheses. Again, that's the toughest part because now we're just going to simplify. So if I take a look here, remember squared means we're multiplying something by itself. So -2x times -2x is +4x squared. And then we're going to distribute this +4, and that's going to get me to a -8x. And then the -3 is just going to hang out. So I end up with this quadratic. I've combined all the like terms I can. It's written in standard form, meaning in order of descending exponents. And that's all I can do. Ooh, let's up it a little bit more. Example 4, if you need to pause, this one's a little longer, jot down ex4. All right, I'm going to treat this like 2 problems. Okay, I'm going to deal with that left side first. So that left side says start with the f function. All right, f function. It says -2, and wherever there's an x, I'm going to put a parenthesis. And it says, hey, inside, we're going to plug in h for x squared minus 2x. Okay, let's look at the right side. The right side just says g of x. So there's no compositions here. I'm literally just writing out the g function. Let's take care of that left side. I'm going to have to distribute. Now we're just going through the operations and simplifying. So I need to distribute -2 to get -8x squared and +4x. Watch your signs. And on the right side, I'm just going to bring down that g function. And now, because it's addition, there's no special rules. We can add in any order. And let's combine like terms. So I always like to underline my like terms. I see I have -8x squared and a 1x squared. That gets me to a -7x squared. Then I see that I have a +4x and a +4x. That gets me to a +8x. And I have this lonely constant by itself, and it's just going to hang out at the end. We're going to amp it up a little bit more, believe it or not. This is short to write. EX5, we're going to find h of j of x. Let's start off with h. We're going to write out the h function, but wherever there is an x, I'm going to put parentheses. Wherever there's parentheses, I'm going to substitute in j. J is x minus 5. This is a binomial. All right. So that's the toughest part. But now we really have to recall some previous knowledge here. Squared means I'm multiplying by itself. Look at how this looks. Please write it this way. Still have a 4 out front. A lot of you are going to want to distribute that squared. You can't because it's a binomial. So we need to FOIL or double distribution, multiply binomials. I'm going to choose double distribution, meaning I'm going to distribute that x twice to get x squared minus 5x. And then I'm going to distribute the negative 5. I'm going to use a different color here. The negative 5 to both of them. That gets me another negative 5x and a positive 25. I can combine like terms inside. There's a negative 10x. And now I can distribute that 4 because that 4 is being multiplied by everything. Oops, 4dx plus 100. Let me tighten that up a little bit. Now don't forget, I've got that right side over here. I have a negative 2 that I needed to distribute as well. So this becomes a negative 2x plus 10, right? Negative times negative. Therefore, if I bring this down, I have a negative 2x plus 10. And now I'm dealing with combining like terms. I'm running out of room here a little bit, so I'm going to write this in purple off to the side here. I have a single 4x squared. Okay. I have negative 40x's and negative 2x's, so I have negative 42x's, like terms, right? I have a positive 100 and a positive 10 for a positive 110. So the substitution part, again, it should be the hardest. It wasn't too bad, but what we're really going to keep an eye out for, and if you're a highlighter type of person, is this right here. Remembering that if you square a binomial, you have to double distribute. All right, let's take a look at one more. Give yourself a second to jot down EX6. You'll notice this one's special because it has equals 0. Okay, so we're actually going to create an equation and not an expression. So let's start off the way we do every other example. We start off with h. I'm going to write out the h function, but wherever there's an x, I'm going to put a parenthesis. It's all equal to 0. So that's what's new right there. Inside, wherever there's a parenthesis, I'm going to plug in f of x, which is a negative 2x. So most of that looks the same. We've just got an equal 0 on the end. All right, well, let's deal with this one first. A negative 2x times a negative 2x, right? Because that's what squared means, gets me a 4x squared. But I still have that 4 outside. I just brought that down, right? I'm going to take care of the right side here. A negative 2 distributed in would get me to a positive 4x, right? So all of this becomes positive 4x. And let's bring down that equals 0. Okay, well, let's distribute. 4 times 4 is 16x squared plus 4x equals 0. All right, we have an equation to solve with multiple variables, which means we need to factor. Okay, let's go back to that summer packet. This is what you needed to know coming into class. So first, I see that I have a binomial. So I'm going to try to take out a GCF first, which would be 4x. If I divide out a 4x, I have 4x plus 1 remaining. I now have factored. That's all I can do to factor. So what that means is I need to take each piece, each factor, and set it equal to 0. So 4 times what is 0? 0. So x equals 0. Or you could show your work, right? Divide by 4, you'd still get 0. On the blue equation, if I subtract 1, I've got -1, divide by 4, I'd have x equals -1/4. Okay, solving 1 and 2-step equations. That's what we're working on in Algebra 1 right now. So factoring is going to play a big role. We're going to recall all of that factoring information from your previous classes. So if you need to review that, seek out assistance, Sabre Center, videos, let me know what you need. So key thing here, again, I'm just going to stress it. If there's an equals, that means you're going to solve in the end. If you're dealing with an equals with a squared, you're likely going to have to factor. So one of my suggestions would be for practice is to rewrite this question and try reworking this on your own, just to recall that information sometime without my voice in the background. All right, as always, for your practice, please check Google Classroom to see what your task is. If you need any assistance, let me know. And until next time, have a good one.